welcome back to the QST YouTube channel. Today I'll be explaining the course revision from 5.4.2 till 5.6. First I'm gonna start with the G2 questions and the G1 questions, and then I'll move on to the T questions. Let's start. So first we're gonna start with 5.4.2 G2 questions 21 and 22. Can I just move back? 21. Okay. The diagram below shows a curve, a part of a curve y equals to 2 into 1 plus 3x to the half at a point A lying on the curve. The line AB intersects the x-axis at B80. Find the volume of the solid. Okay. So, for the volume under the curve, right? So, this part from 0 to 5, right? It's just the curve. So what are we gonna do? We're gonna integrate pi times the function squared. So pi into integral from 0, till 5, 2 into to the power of half means radical. 2 into 1 plus 2 into radical 1 plus 3x, all of this function squared, right? So I'm gonna plug this into the calculator. So from 0 to 5, 2 into radical 1 plus 3x, all of that squared, you're going to get 170 pi. But now here we're not done with the entire question. There's still this volume, right? And for that's why they're talking to us here about volume of a cone, right? So whenever we see a line, like area under a line, that's when we have to do volume of a cone. Volume of the cone, they gave it 1 over 3 pi r squared h. Height will be the horizontal, right? Height horizontal h. So from 0 to 5 is 3. So the radius would be the vertical. So from 0 to 8 squared, so 64, times the height, which is the horizontal distance, 3, which is going to give you 64 pi. Since we need the total volume, we add these two together to get 234 pi. That's it for question 21. Let's move on to question number 22. The diagram below shows the graphs of two horizontal lines, and the function y is equal to f of x is equal to kx squared plus m, where k and m are constants. Point A has coordinates 1, 9, and point B has coordinates 2, 21. So first, let's start with finding k and m. What we're gonna do for questions like these, we're gonna create a system of equations using the points they gave us. So let's start with 1, 9. So 9 is equal to k times 1 squared, which is k, plus m. And then for the other point, 21 is equal to 4k, right? Because 2 squared plus m. We can subtract both sides, cancel. 21 minus 9 is 12, is equal to 4k minus k is 3k. So k is equal to 4. Perfect, right? But they also want m, don't forget that. So what we're gonna do is substitute in one of these equations. So 9 is equal to 4 plus m is equal to 5. So the equation is 4x squared plus 5. We're officially done with part A. Now let's work on part B. The shaded region is rotated 360 degrees around the y-axis. Find the volume of the solid generated. When they say rotated around the y-axis, that means we need to write it in terms of x, but to make it easier you can write in terms of x squared, because we just need to like integrate that part. So integral, since they said y-axis, we use the y, so from 9 to 21 you isolate x squared, so y minus 5 over 4. So again, you integrate from 21 to 9 x minus 5 over 4, which is equal to 30 pi. I just didn't put the pi here, it's just meant to be 30 pi. And now that we're done with question 22, we should move on to section 5.6, G2, question 29. So question 29, right here. Find the values of the improper integrals if an integral diverges, say so. So I'll just work with it one by one. So for part A, let's start with the limits, and let's take the 32 out since it's a constant. So third limits from b to infinity, 32 into the integral from 1 to b, x to the negative 1 over 8. You integrate like normal, right? So limit as b goes to infinity, 32 times 8 over 7 into x to the 7 over 8. So from again 1 to b, so we're gonna be out here with I think 196 over 7 into, we substitute now b by infinity, right? Since we said we're using the limit as b approaches to infinity, so infinity minus 1. This will just give us infinity, which is the right answer. Now for part B, they want us to check out 14 over 8th root of x. Again, you can do the same thing. Limit, but here, in this case, right, we cannot have 0 in the denominator, so that's why we're gonna do all of this again. And I think I told you guys this before, since it's from 0 to 1, we need to take a number in between, so we'll take 0 plus, right? Limit as c goes to 0 plus 14 into the integral of from c to 1 x to the negative 1 over 8. Then again same thing, limit as c goes to 0 plus, you integrate, you get 14 times 8 over 7, which is 16, into 8 x to the 7 over 8 from 1 to c. You do now you subtract, you just simplify. So 1 to the power of 7 over 8 is 1, minus 0 plus to the power of 7 over 8, which is 0, because 0 plus is really close to 0. To the power of 7 over 8, it will just be 0. This is equal to 16. So now we will be moving on to 6.1, question 6, page 37. Finally finished all of this area stuff. Now we move on to sequences. Consider the sequence un, which is defined recursively by un is equal to 4un minus 1 plus un minus 2, with u1 is equal to 2 and u2 is equal to 5. So u1 is equal to 2, u2 is equal to 5, u3 we need to find it to find u4, and u4 is what we're looking for right now. Now to find u3, right, so u3 is equal to 4 times 5 plus 2, which is equal to 22. Then you do the same thing for u4, so u4 is equal to 4 times 22 plus 5, which is equal to 93. Now we move on to 6.2, 10, 11, and 14. So let's start with question 10. AN is an arithmetic progression in which A24 minus A8 is equal to 176. Now look, I have my way and my teacher has her way. I'm gonna use my way since I don't really understand my teacher's way, so I'm sorry if this causes any confusion with you from now. But what I'm doing here, right, A24, or let's start with the general rule, AN is equal to A1 plus N minus 1 into D, right? Now let's write this. A24 is equal to A1, N is 24 in this case, so A1 plus 23D, and then A8 is equal to A1 plus 7D, and we subtract both sides, so A24 minus A8 they said is equal to 176, and then the A1 will cancel out, so 176 is equal to 16D, D will be equal to 11. Number 11. The third term of an arithmetic progression is 12, and the 10th term of this progression is 33. What is the 35th term? Okay, let's do this. This came in the CA today, by the way, so this is probably gonna come in the periodic. So again, same rule. So 12 is equal to A1 plus 2D, right? Since N is 3. And then 33 is equal to A1 plus 9D. Then you subtract both sides again. 21 is equal to 7D. D is equal to 3. Good? But to find the 35th term, we need to find A1. So we substitute D in any of these equations. So let's say 12 is equal to A1 plus 2 times 3. 2 times 3 is 6, so we get that A1 is equal to 6. Good? Now they want the 35th term, which is the main objective. So 6 plus N minus 1, they said the 35th, so 34 times 3. So we plug this into the calculator as always. 6 plus 34 times 3, which is equal to 108. Number 14. The first term of an arithmetic progression is negative 4, and the 14th term is 61. What is the sum of the first 20 terms in this progression? Okay, look, when they're speaking of the sum in an arithmetic progression, right? The rule is n over 2 into 2a1 plus n minus 1 times d. Simple as that, right? So again, we're gonna build a relation. The first term is 4, the 14th term is 61. So a14, which is 61, is equal to negative 4 plus 13d. You will get d is equal to 5. Good. So now we can substitute it here in the equation here, right? So n over 2, which is 10, into 2 times negative 4, which is negative 8, plus n minus 1, which is 19, times 5. Again, let's plug this into the calculator. 10 into negative 8 plus 19 times 5, which is equal to 870. So now we are going to be moving on to 6.2, question 24, page 39. The sum of the first 5 terms in geometric progress. Wait, no, not this one, right? What was the question again? Question 24, my bad. This one. A ball is dropped and bounces such that the height of each bounce is 50% of the height of the previous bounce. The first bounce of the ball reaches a height of 6 feet. The height of the ball on its 8th bounces. Now this will probably come. Not probably, it's 100% gonna come. Let's all admit it. Okay, look. When it comes to geometric, when they want the nth term, it's equal to g1 times r to the power of n minus 1, right? And that's what they're looking for now. So g1 is 6. They said the first bounce is 6 times r, which is 0.50% of the height. It's not added or subtracted. 0.5 of the height, which is the ratio. 0.5 to the power of n minus 1. They want the 8th bounce. 8 is n in this case, so 8 minus 1 is equal to 7, obviously. So 6 times 0.5 to the 7 is equal to 3 over 64, which is the answer. Now for part B, the total vertical distance traveled by the ball from when it first hits the ground until it hits the ground at the end of its 10th bounce is 3069 over n feet. Find the value of n. Notice how they said total vertical distance, right? So the sum of a geometric sequence is equal to g1 into 1 minus r to the n, close brackets, over 1 minus r. Okay, so g1 is 6 into 1 minus 0.5 to the 10 over 1 minus 0.5. So we're gonna plug this into the calculator. 6 into 1 minus 0.5 to the power of 10 over 1 minus 0.5. That is 3069 over 256. But that is not the answer, right? Since it's the total vertical distance, right? Let's see, I'm dropping a ball from here, right? It's gonna go down that height, then it's gonna come back up. So we're gonna need to multiply this by 2, which is equal to 3069 over 128. Okay, now let's move to part C. Whenever they say no matter how many times the ball bounces, the total vertical distance will not be greater than. What we're doing here is sum to infinity, right? So the rule for that is g1 over 1 minus r. As simple as that. So 6 over 1 minus 0.5 is equal to 12. But once again, we do like what we did with part B. Since whatever you throw down always comes back up, we're gonna have to multiply 12 by 2, and that is going to give us 24. And that's the right answer. Now we have the last two questions before we move on to the main focus of the video, the T questions, where most people will be focusing and everything. So let's move to question number 39. Rania receives each week 35% in her allowance. In a certain week, she used 30% of her allowance to buy snack bags for her pet. Each bag costs 1.5. How many snack bags did she buy? Let's analyze the question. She received $35 in allowance. That's nice. In a certain week, she used 30% of it. 30% of her allowance. So 30%, which is 0.3 times 35 to get snack bags for her pet. Each bag, so not the entire thing, each bag. So one bag is 1.5. 1.5x, because that we're looking for the amount of snack bags. So what we're going to do is 35 times 0.3 divided by 1.5, you'll get that x is equal to 7. Number 40. Molina bought 5 bags at garden soil that were all at the same price. The bags were discounted by 40% of the original price. At the checkout, she used a $10 coupon that she applied toward the entire purchase. She ended up paying $32 for her purchase. What is the original price in dollars of each bag of soil? Now let's start backwards for this question. She paid $32, right? But she saved 10. So 32 plus 10. Perfect, right? And then they said the bags were discounted at 40% by 40% of the original price. That means she paid 100 minus 40% is equal to 60%, right? So she paid for 60% of the original price. So 0.6 times. They say that she bought 5 bags. So 0.6 times 5 times the original price, which is what we're looking for. I think that's as clear as it gets. So 42 is equal to 3x. X is equal to $14. As simple as that. Okay, now we're gonna begin with the top questions, starting grid T questions for chapter 5, from question 36 to question 39, and let's start. So 36. The diagram shows the curve for which the derivative is equal to negative px cube p over x cube, where p is a constant. The curve passes through the points 120 and 45. Here they said p is a constant, so what we can do, okay, wait, I'll just take it into a page, so like this. Okay. Let's just make it smaller. Okay. So if we want the function, what we're gonna do is we're gonna integrate the derivative, right? So what we're going to do is we're going to integrate, I just put negative p outside since they said p is a constant, x to the negative 3, right? This is going to be equal to p over x squared plus c. Now what we're going to do here is they want to show by integration that the equation is equal to y is equal to 16 over x squared plus 4. So what I'm going to do now is that I'm going to create a system of equations and then subtract so we can cancel out c, right? So let's start with 120. 20 is equal to p plus c, right? And 5 is equal to p over 16 plus c. We're gonna subtract both sides. We're going to get 15 is equal to 15 over 16p. You're going to get p is equal to 16, right? Perfect. So now what we can do with this, we can substitute p by 16 here to get that c is equal to 4. We just solved part A just like that. So it's going to be 16 over x squared plus 4. The point D lies on the curve and has x coordinate 2. Find the area. Area is not included in this section, so but I'm gonna do it anyways just in case it comes. So we're going to integrate from the shaded region, which is from 1 to 2. Then what we're gonna do is just integrate the function. So we're going to integrate from 1 to 2 the function, which is 16 over x squared plus 4. 16 over x squared plus 4, which is going to give you 12. Number 37. The diagram below shows part of the curve y is equal to b over x, where b is a positive constant. Given that the volume obtained when the shaded region is rotated through 360 degrees about the x-axis is 27 pi, find the value of b. So let's just do the same thing again. Shrink it like this, and let's start. So when they're speaking about volume, right? So 27 pi is equal to pi times the function squared, right? So from 1 to 4, the function squared, which is b squared over x squared. But here they said that b is a positive constant, so we can just, and also we can cancel pi. So 27 is equal to b squared times the integral from 1 to 4 x to the negative 2, right? Then simplify even more. 27 is equal to b squared. The integral of x to the negative 2 is x to 1 negative 1 over x from 1 to 4. Then we're gonna simplify, right? So 27 is equal to b squared times negative 1 over 4 plus, because negative positive plus 1, you're going to get b squared is equal to 36. Here we take the positive number because here they said b is a positive constant, so b is equal to 6. As simple as that. Now we move to question 38, right? Yeah. Here. The diagram shows the part of the curve y is equal to x plus 8 over x, which has a minimum point at q. The line y is equal to 6 intersects the curve at the points s and t. Find the coordinates of s, t, and q. Okay. Let's just first solve part A. So let's find s and t. S is equal to something 6, right? Since it intersects the line y equal to 6. Also t, same thing. Something 6. So 6 is equal to, you take common denominator, so x squared plus 8 over x, so 6x is equal, you just take it all to one side, you're gonna get x squared minus 6x plus 8 is equal to 0. You're going to get s is going to be, you're gonna get x is 2 and x is 4, right? Since s is behind t, as we can see in the graph, so s, the coordinates of s will be 2, 6, and the coordinates of t will be 4, 6. But now here comes the tough part. Q, right? Here they said a minimum point, which means the derivative of this is equal to 0. So we're gonna derive, for those who don't remember, ax to the n, we're going to multiply a times n times x to the power of n minus 1, right? Which is what we're going to do here. So, and before I start, the derivative of any variable alone is 1. So 1 plus 8 times x to the negative 1. You're going to get negative 8 over x squared. So 1 minus 8 over x squared is equal to 0. You take 8 over x squared to the other side and cross multiply, you get x squared is equal to 8. You get x is 2 radical 2 because we are on like the positive side. So x is equal to 2 radical 2, right? But to get y, we're gonna need to substitute 2 radical 2 on the curve, right? So wait, let me just q 2 radical 2 and let's simplify. So we do 2 radical 2 plus 8 over 2 radical 2. Plug this into the calculator. So again, 2 radical 2 plus 8 over 2 radical 2, which is 4 radical 2. We finished part A. Find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Look, here we have a line and a curve, right? And when we do this, we do farthest from the line of revolution minus closest. So let's just take it in blue. This is how far it is from the line, and then this is how far it is from the curve. There is not that much of a difference, but it's obvious that the line, so 6, is greater than, I'll just write f, the function. So what we're going to do, from, they want the shaded region, which is from S to T, which is from 2 to 4. We do nothing with Q since they just want from 2 to 4. Just give me a second. From 2 to 4. Right. What we're going to do is biggest squared, which is 6 squared, minus the function squared. So it's x plus 8 over x, all of it squared. Just let me plug it into the calculator. 36 minus x plus 8 over x, all of that squared, which is going to give you 16 over 3. Last question for the chapter 5t questions. The diagram shows part of the curve 2 radical x minus x. The curve has a maximum point at f and intersects the x-axis at O and G. Find the coordinates of f and g. Look, so for part A, just they want the derivative of this, right? So what we're going to do is derive. So 2 times x to the half minus 1. What we're going to derive, right? So we're going to get 1 over radical x minus 1 is equal to 0, right? But here we want x, we don't want just an equation. So we're going to get x squared is equal to 1, x is equal to plus minus 1, but here they want the positive, so x is equal to 1. So since x is 1, how do we find y, right? 1, we're just gonna substitute in the function, we're going to get 1 as well. Simple as that. For part B, find they want g. We're just gonna equate it to 0 since it intersects the x-axis. So 2 radical x is equal to x. Square both sides and take 2 radical x, all of it squared to the other side. You're gonna get 0 is equal to x squared minus 4x. You're going to get 0 and 4. You pick 4 since O is the origin. We're trying to find g, so 4. And then you substitute again 4 in the curve. You're going to get 0, right? Since it's at the x-axis. Done. Find the volume obtained when the shaded region is rotated 360 degrees about the x-axis. So just integrate from 0 to 4, 0 to 4, the function squared, so 4x squared, 4x minus x squared, plug that into the calculator, from 0 to 4, 2 radical x minus x, all of that squared. You're going to get 32 over 15 pi. Actually, don't just do this, you take the whole function squared. It makes life so much easier. And now we move on to the chapter 60 questions, which are easier, but they are like a lot more. So 25, 27, 28, 30, 32, 36, 34, 36, 38. Okay, and now let's start. Question 25 of this chapter. In an arithmetic progression, the first term is 0.6, the fifth term is 5, and the last term is 109.5. Find the sum of all of the terms in the progression. So first we need to find d, right? So 0.6, 5 is equal to 0.6 plus and minus 1 times d. You're going to get d is equal to 1.1. But now we need to find n of 109.5. So 109.5 is equal to 0.6 plus n minus 1 times 1.1. You distribute 1 plus 1.1n minus 1.1. You get n is equal to 100, right? And then they want the sum of all of the terms. So what we are going to do is the rule of the sum. N over 2, which is 50 in this case, into 2a1, which is 1.2, plus 99 times 1.1. You plug that into the calculator. 50 into 1.2 plus 99 times 1.1, you get 5505. On to the next question, which is number 27. The second term of a geometric progression is 16 and the sum to infinity is 64. Now this is one of the harder questions of this, but let's do this, right? G2, we know that G2 over G1 will give us the common ratio, right? Okay, but here we have the sum to infinity, which is G1 over 1 minus r. We need to write this in terms of G2. So that would be G2 over r. So what I would do is G2 over r times 1 over 1 minus r, or divided by 1 minus r. You could do both ways. Is equal to 64. They gave us G2 already, so you plug this into the calculator. So 16 over r times 1 over 1 minus r is equal to 64. You get r is equal to 1 over 2, right? So the first term would be, by using this rule we found earlier, G1 would be 32, right? Okay. An arithmetic progression has the same first and second term as the geometric progression. So A1 is equal to 32, A2 is equal to 16, right? Okay, so to find the common differences, they want the first 11 terms. We do 16 minus 32, which is negative 16. And then we do the the sum rule, 11 over 2 into 2 times a1, which is 64, plus 10 times negative 16, which is negative 160. Plug this into the calculator as always. 11 over 2 into 64 minus 160, you are going to get negative 528. And then we're going to do number 28. The first term of a geometric progression is 270 and the fourth term is 80. What is the common ratio? Look, the rule for Gn is equal to G1 times r to the power of n minus 1. So 80 is equal to 270 times r cubed, right? Plug this into the calculator. You get that r is 2 over 3. The second and third terms of this geometric progression are the first and fourth terms of that arithmetic progression. So here we have the second term would be 270 times 2 over 3. So G2 is equal to 180, which is equal to, at the same time, A1, my bad. And then the third term, so G3 would be 180 times 2 over 3, which is 120, which is equal to A4. So again we do the AN rule, so 120 is equal to 180 plus, plus n minus 1, which is 3d. You get d is equal to negative 20. So you find the sum of the first 9 terms by doing the same rule. 9 over 2 into 2a1, which is 360, plus 8 times negative 20. Again, plug this into the calculator. 9 over 2 into 360 minus you're going to get 200 times 9 over 2, you're going to get 900. Okay, now we move on to number 30. The eighth term of an arithmetic progression is 49 and the sum of the first 5 terms is 20. Find the first progression and the common difference. Find the value of n. This should be really easy. So a1 plus 7d is equal to 49, and then you do the sum rule, so 5 over 2 times 2a1, which was what we're trying to find, plus 4d is equal to 20. What you could do here, we're trying to to keep a1 just a1 plus something d is equal to another number for both equations. So what we're going to do is multiply by 2 over 5 on both sides, and we're going to get 8, right? And then we're gonna factor by 2 and divide again on both sides. So a1 plus 2d is equal to 8. Let's just remove this. And then you subtract, so you can cancel this and this. 5d, wait, sorry, this should be 4, since we divided by 2 on both sides. It's equal to 45. D is equal to 9. And then we substitute here. I get a1 is equal to negative 14. And then they want the nth term, so negative 14 plus n minus 1 times d, you distribute, so plus 9n minus 9 is equal to 4. You get n is equal to 3. That's it for 30. We have, if I'm not mistaken, 32, 34, 36, 38. A bank loan got $3,000. The loan is repaid by weekly payments, which are an arithmetic progression. The first payment is $30, and the debt is fully repaid after 12 weeks. Find the 10th payment. So here they said Sn is equal to 3,000. Right? Do not get confused with the compound interest. That's a whole other rule. The first payment is 3,000. So, and they said after 12 weeks. So we're gonna do the Sn rule where n is 12. So 6 into 60 plus 11d is equal to 3,000. So you plug this into the calculator. 6 into 60 plus 11x is equal to 3,000. You get d is equal to 40. And then you do the an rule, so a10 is equal to a1, which is 30, plus n minus 1, which would be 9 times 40. Plug this into the calculator. 30 plus 360, you get 390. Find the sum to okay. Find the sum to infinity of the geometric progression whose first term is 18 and whose second term is 12. First we need to find r is 12 over 18, which is equal to 2 over 3. And then you do g1 over 1 minus r, so 18 over 1 minus 2 over 3, which is 1 over 3, or just 18 over 1 minus 2 over 3. Plug this into the calculator. 18 over 1 minus 2 over 3. You get 54. That's 32 done. Let's move to 34. The first term of an arithmetic progression is a, and the common difference is d, where d is not equal to 0. Write down the expressions of terms a and d for the first 3 terms, 11th and 17th term. So what we're going to do is the an rule, right? So a1, that's the first term. 11th term would be a1, I'll just call it a as they said here. A plus n minus 1 times d, 10d, and then a plus 16d for the 17th term. The first term, the 11th term, and the 17th term of the arithmetic progression are the first 3 terms of a geometric progression. Show that a is equal to negative 25d, right? So what we're going to show is that what we're going to do now is g2 over g1 is equal to g3 over g2. Each of these are equal to the common ratio, which is what we'll need for part C. So a plus 10d over a is equal to a plus 16d over a plus 10d. You cross multiply, you get a plus 10d squared, right? So I'll just simplify it. A squared plus 2ab, which is 20ad plus 100d squared is equal to, if you distribute a into a plus 16d, a squared plus 16ad, the a squareds will cancel. You take the 16ad to the other side and the 100d squared, you also switch it. We just want to keep everything with a on one side and everything with only d on one side. So 4ad is equal to negative 25d squared. You divide by, sorry, negative 100d squared, we're gonna get to there. You divide by 4d on each side, you get a is equal to negative 25d, and then they want to find the common ratio, so you're gonna substitute negative 25d instead of a, let's say here. So negative 15d over negative 25d, you're going to get 3 over 5. Let's go to question 36. The fifth term of an arithmetic progression is 36 and the sum of the first 5 terms is 150. Find the first term and the common difference. The first term is, okay, I believe this question 36 does not need explanation. I'll just make sure. 34, 32, 30. Right. Yeah, we do not need to do another explanation on 36 since its concept repeated. And 38, which is the last question for today. In arithmetic progression, the sum Sn of the first n terms given by find the first term, right? So S1 is just going to be A1, right? S2 is going to be A2 plus A1. So what we're trying to find here is A1, and then we're gonna find S2 to find A2 and then subtract, right? So what are we gonna do to find A1? We're gonna substitute n by 1, so we're going to get 12 minus 3, which is 9, and then S2 is going to be 24 minus 12, which is 24 minus 12, which is 12. So 12 is equal to A1 plus A2. We got A1 to be 9, so A2 will be 3. We're not done with the question. They want the common difference. We're just gonna do A2 minus A1, and we're going to get D is equal to negative 6. Thank you guys so much for watching this video. I wish you guys the best of luck in all of your exams, whether it be math, mechanics, so on and so forth, and see you next time. Goodbye.